In this video, we're going to try 3 different examples of congruent angles associated with parallel lines. So this first one is a 2-column proof, and it should look similar to some of the proofs you did in section 5.2. The only difference with this proof is that we are given 2 lines are parallel. So we're given that line BC is parallel to line PQ. And I'm also going to put those parallel line tick marks there. The other given is that BC is congruent to PQ. So I'm going to put congruent tick marks, and that angle B is congruent to angle Q. And from there, we want to prove that segment AP is congruent to segment CR. So right away, when we see that first given, those parallel lines, we should be looking for angles. Anytime you're given parallel lines, you're looking for angles. So which angles can we either prove congruent or supplementary? Sometimes this may be a little bit hard to see. So the next thing I try to do is I use my colors and I highlight the transversal that goes through those 2 parallel lines. So AR would be the transversal. So now hopefully it should be easier to see which angles you can prove. Angles 1 and 2. So it's always the angles that are formed by the transversal and the parallel lines. Now we just need to determine what type of angles 1 and 2 are. Well, they're on opposite sides of the transversal, and they are actually outside of the parallel lines. So those would be an example of alternate exterior angles. So right after that first given, I would say angle 1 is congruent to angle 2, because if 2 parallel lines are cut by a transversal, then alternate exterior angles are congruent. Now, after I copy down my next 2 givens, I have enough information to prove that the 2 triangles are congruent by angle, side angle. Now, I do want to prove that segment AP is congruent to segment CR. Those are not segments in the 2 triangles, but in order to prove that, we will need to get segment AC congruent to segment PR. And the reason for that would be by CP/CTC, since those are corresponding sides. And then I can prove those 2 segments are congruent by the addition property. So like I said, these proofs are very similar to the proofs you saw in the last section, except you're just going to be given that 2 lines are parallel instead of trying to prove that. Moving on to our next example, we have a diagram that's labeled, and it says determine if line A is parallel to line B. There's actually 2 different ways to go about doing this. You can either try to prove it directly or indirectly. Right away, I notice that I have a set of vertical angles. So I know that vertical angles always must be congruent. So if I were to prove this directly, I would start by setting my 2 vertical angles equal to each other. And then I would solve that for x. So I'd subtract 30, and I get 5x equals 40. So divide by 5. And you should get x is equal to 8. And then I would substitute that 8 into these 2 angles. So we know that 5 times 8, that would give me 40 plus 30, which is 70. And if I substitute it up here, I get 2 times 8, which is 16, plus 10. And that would equal 26. Now, in order for line A and B to be parallel, these are interior angles on the same side of the transversal. And we know that interior angles on the same side of the transversal must be supplementary. 70 plus 26 does not equal 180. So therefore, A is not parallel to B. And usually I would always try to write some sort of explanation even if it's just a sentence. So I'd say A is not parallel to B because interior angles on the same side of the transversal are not supplementary. So that's how you could prove it directly. Now I know some people like to, well, let's assume that A is parallel to B, and they do it indirectly. So if we assume that A and B are parallel, then we know that interior on the same side of the transversal would have to equal 180 degrees. So your equation would be slightly different if you're proving it indirectly, if you're assuming that they're parallel. And then you would go ahead and solve this equation for x, and you would get x is equal to 20. Then I would substitute it in here. I'm just going to erase my old work. I would substitute it in for the 5x plus 30. So 5 times 20, that would be 100 plus 30. So I would get that this angle is equal to 130 degrees, but this angle is equal to 70. So vertical angles are not congruent. Therefore, A cannot be parallel to B because when we assumed that it was, and we plugged in our answer for x, then vertical angles were not congruent. And that's a contradiction of a theorem. So either way, you can either do it the first method, which is directly, or the second method, which is indirectly. Just make sure you include at the very end a sentence explaining your reasoning for why or why not. Now the last type of example in this section is called a crook problem. And you know it's a crook problem if it has kind of these little points to it in the middle, these zigzags in the middle. Those are called crooks. So initially, they're kind of a little bit intimidating, but if you just follow my steps, these problems are fairly easy. Now, I gave you a little bit more complicated example than some of the ones you may see in the homework, just so we could do the hard example together. So anytime you have a crook problem, you start by drawing a line through the point of the crook that is parallel to the other two parallel lines. So in this case, since there are two crooks, I'm going to draw two lines, one through each point. So there were two crooks, so I drew two parallel lines through the points of those crooks. Now I'm just going to start labeling things until I get to this angle 4, which is what I'm trying to find the measure of. Now I know that if these two lines are parallel, these top two lines are parallel to each other, then alternate interior angles must be congruent. So this small angle here would have to be 30 degrees. Now since that entire angle was 90, and I know the top part of it is 30, 90 minus that 30, that means the bottom part of that angle must be 60 degrees. Now if I look at the two middle parallel lines, the blue ones, I also know that alternate interior angles must be congruent. So I know the top part of angle 4 would have to be equal to 60 degrees because those are alternate interior angles. Now I can't continue any further, so now I'm going to go to the very bottom, and I'm given the bottom angle is 115 degrees. And I know the bottom half of the angle below the 60 degrees would have to be the supplement of 115 because those are interior angles on the same side of the transversal. So the bottom part of angle 4 would have to equal 65 degrees. So now when it asks me to find the measure of angle 4, I would just add those two angle measures together. I know the top part of angle 4 is 60, the bottom part of angle 4 is 65, and if I add those two things together, I get 125 degrees. And that's your final answer. The measure of angle 4 is 125 degrees. So hopefully this kind of gives you a little bit of a better idea of the types of examples that you're going to see in this section.